going to construct the understanding together. And it says use the graph to estimate the corresponding x values for each of the given y values. So I'm going to circle this y equals 4 in purple. And if I drew y equals 4, which is a straight horizontal line, there would be 3 places it hits the graph. So I would estimate that if y was 4, x could be 0, -2, or +2. In bright yellow, y equals 9. That would be right up here. It looks like there's 2 places where it hits the graph at y equals 9. I'd estimate that to be -2.6 and +2.6. I'm not sure exactly. But I'm just looking at my graph, what my x values would be there. And finally, in orange, y is equal to 2. My graph, it goes through the graph 4 times. So it looks like just less than 1, just less than 2, just less than -1, just less than +2, or is it right exactly at 1? I can't even tell anymore because my pen is overlapping it. So at the bottom of the page it says that graphing strategies can be used to solve absolute value equations. So an absolute value equation is an equation that has an absolute value in it, and the graphing strategy says, can you graph y equals the absolute value of 2x and y equals 4 at the same time. So you take your left side of your equation and graph that. You take your right side of the equation and graph that. And I chose the colors red and green because on my screen the absolute value is in red. The straight line at y equals 4 is in green, and then you can see where they intersect are going to be your solutions. So our solutions for this one are x equals 2 and x equals -2. Can you double check that? Do they both work? Like if you plug in 2 for x, is the absolute value of 4 4? Yes. Can you plug in -2 for x? Then I'd have the absolute value of -4. Is it also 4? Yes. So we have more than one possibility. So if we go to example 1, it says solve by graphing. I'm going to draw a graph here. And I'm going to graph the one side in blue, and I'm going to graph the other side in green. The green side is the easy part. Y equals 6. Start with that one. That's just your horizontal line. Y equals 6. On Friday, we learned how to graph absolute value graphs. How did we graph absolute value graphs? We graphed the inside, and then we flipped whatever was below up. So I'm going to graph the inside in orange. If I was going to graph y equals 3x minus 6, 1, 2, 3, 4, 5, 6, I'd have a y-intercept of -6, a slope of 3, up 3 over 1, up 3 over 1. Remember, up 3 over 1. Here's my orange graph. Ooh, I like this. Up 3 over 1. Remember that in absolute value graphs, the x-intercept is super important because I'm going to take this orange graph, and to graph the blue one, wherever it was positive, I'm going to draw this like right on top or right beside, that's going to stay the same. Wherever it was negative, it gets So this point on my orange graph, which was 1 comma negative 3, on my blue graph is going to be 1 comma positive 3, and 0 negative 6 is 0 positive 6. And there's my absolute value graph. And my solutions, where do these things intersect? They intersect at 0 comma 6, and they intersect at 4 comma 6. So based on my graph, my solution is x is equal to 0 and x is equal to 4. So if a quiz or test says solve by graphing, you have to do this. Most students will eventually like this algebraic way to solve this better. The algebraic way to solve this looks like this. So I'll show it to you right away. Because some of you, if you get a solve by graphing, you might like the algebraic way as a way to check. So if I have this equation, and I'll start it off here, the absolute value of 3x minus 6 is equal to 6. There's two possibilities that could have happened here. Does it make sense that if the inside of this, the 3x minus 6, which is the inside, if that's equal to 6, does the absolute value matter? No. If the inside is equal to 6, then you'd have no problem solving. The other possibility is this inside could equal 1 and still equal 6 in the end. What could the inside equal? And then with the absolute values, it's also equal to 6, negative 6. So we have these two possibilities. You have the possibility that the inside is positive, and then it wouldn't matter, or the possibility the inside is negative. And sometimes it's shown like this, and sometimes students take it from the piecewise notation and put the negative out in front. So you could have the negative on this side or the negative on that side. Solving this then, here I would move my 6 over, 3x is equal to 12 divided by, look, there's my 4. A lot less work than graphing. And here, if I add 6 to the other side, I get 3x equals 0. There's my 0. The solving is algebraically two things. One, it's a little bit less work because you don't have to draw big graphs. Two, it works nice even if the points aren't nice. Sometimes graphing is like, oh, great. It intersected at a place I can't even tell. So now my graph is not very helpful. That can happen as well. Okay, I'm going to get you to circle 5, 8, and 6.